Alright, free fall problems. I was going to lead with a song, but I don't want to get sued. So here we go. The thing about these problems, not very hard. I know it's like, man, they didn't talk about free falling. They just talked about like running and stuff like that, going like left and right. Well, think about this is like the last problem we did, a runner running a 400 meter or something like that. Think about a runner running from the top of a building straight into the ground. So it's still like a distance problem, right? We just have one more thing to consider. Let's focus it up. Zoop, 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 zoop. There we go. Alright, so let's read the question. An object falls from a high building, ignoring air resistance, because that makes things complicated. What will its velocity be after 6 seconds of falling? So let's highlight what we know. Any numbers usually are important. So 6 seconds, that's our time. Let's circle what they want us to know. Its velocity, especially when you see after, that means that they're looking for its final velocity, right? So let's write off to the side what we know. We know time is 6 seconds. We know initial velocity, because if there's a final velocity, there's initial velocity. At the top of the building is 0, right? So our initial velocity equals 0. This means initial velocity. This doesn't have anything to do with this here. This is the initial velocity here. We also know something else. We know the acceleration, because acceleration is like a universal on Earth. So our acceleration is, anybody remember that? 9.8 meters per second squared. So that's our acceleration. So we know time, we know initial velocity, we know acceleration. Okay? So now, this is your mighty formula chart. Take this with you wherever you go and never lose it until you're done with physics. So again, what are we trying to find? We are trying to find its final velocity after a given time. I'm going to look on these formula charts, and I'm going to look for the one that has everything that's in this question, even the things that are not in this question but are assumed. Like, for instance, acceleration. It's falling, so that's assumed. Initial velocity, that's assumed because it's at the top and then it goes in initial time. So when I look at this one, it doesn't talk about displacement. I don't need average velocity because I don't want average. Average is not like a finality, right? I want something with a final and initial. So I look at these two. I see acceleration equals final velocity minus initial velocity divided by the change in time. And I see acceleration is final velocity squared minus initial velocity squared divided by twice the displacement. One of these two, we have no idea one of the variables, and we don't have a way to find it. And that's this one. We don't know this because displacement, this gives us nothing about displacement. The only number it gives us is time. So we're going to use this one. So with that being said, let's start it up. Our acceleration equals, I know we're trying to find final velocity. It's okay that it says A equals. Okay, so don't freak out like, Mr. Barris, we're trying to find final velocity. Why are you saying acceleration equals? It's okay, no worries. Acceleration equals our final velocity minus our initial velocity, remember that 0 that I talked about, divided by our change in is a triangle, time. So, rewrite time. Make it many steps. It'll help you if you have to look back. Okay? So, our acceleration, what was our acceleration? 9.8. So, 9.8 equals final velocity. That's what we're trying to find. So, final velocity minus initial velocity. Before it gets dropped, it's 0, right? 0 divided by the change in time. Well, at the beginning of like our thing, the time is 0, so it's final minus initial, so 6 minus 0, which is 0. Now let's rewrite it again. We're going to rewrite this a couple times. 9.8 equals final velocity divided by 6. Okay, this is not what we want quite yet. All right, so what we're going to do, we're going to start label these steps because I'm going to come down here. So 1, 2, 3, 4. So this is our 4. 1, 2, 3, 4. So now what we got to do, and we're going to come back up here to switch it. It's trying to divide in over here, so we need to cancel it out, right? So I'm going to multiply this side by 6, so I can multiply this side by 6, right? So when you multiply this side by 6, these cancel. So now we have, and I'm going to flip them, okay? Final velocity equals 9.8 times 6. So final velocity equals 9.8 times 6. So that should be final velocity equals, give you guys a few seconds to do that, 58.8. Or you could just put 60, which would be fine, and then it's going to be meters per second. Cool, so we did it. Not too bad, right? Not too bad at all.